There are two main roles RxJS has served in Angular applications: to coordinate asynchronous events dealing with race conditions and handling complex asynchronous data flows, and as a basic reactive building block. This second thing is what signals are coming for, to provide an alternative to RxJS as the primary basic reactive building block in Angular. But why? A sentiment I have been seeing a lot is that Angular already uses RxJS and we have behavior subjects which seem to provide the same basic functionality as signals. So why didn't the Angular team just fully embrace RxJS, which it already heavily integrates, instead of introducing this whole new thing which has less power than RxJS? So to cut straight to the point, signals are better in multiple ways over a behavior subject as a basic reactive building block for Angular, even though they might look similar on the surface. So this video is all about giving some solid examples of where signals are actually better. So a signal looks like this, and a behavior subject looks like this. If the concept of a signal in Angular is new to you completely, you might want to check out my other video first, which I'll link in the description. So you could argue the signal syntax is slightly simpler here, but it's trivial. The real differences start when we want to access these values. Accessing the values in the template looks similar enough. With signals, we access the value directly by calling it as a function. With a behavior subject, we can just use the async pipe to pull the value out. And technically, it is also still possible to just access the behavior subject's value directly at this point with .value or .getValue. And things also look similar in the class as long as we want to access these values imperatively. But what about when we get into computing derived values? That is to say, if a signal or behavior subject gets a new value, we want to run some kind of computation on that value to produce some other value. Again, reasonably similar syntax here. You could argue the signal syntax is slightly simpler, but still the differences are pretty trivial. But this is where we start to run into one of the key advantages of signals. As soon as we try to pipe onto a behavior subject to use some operator like map, it ceases being a behavior subject and turns into a standard observable. This means we can no longer access its value directly, we have to subscribe to it, and it also means we are now in the world of observables and all of the concepts they bring to the table. Subscribing and unsubscribing, the async pipe, unintended consequences of multiple subscriptions and side effects, hot and cold observables, and so on. If we want to access the value of our double count in the class with signals, we can just do this. But to get the value of our double count with the RxJS example, we will need to create a subscription like this. But we've created a subscription here, so that means we also should make sure we have some kind of unsubscribe strategy as well to avoid any unwanted behavior or memory leaks. Now, to speak on behalf of reactive, declarative RxJS fans here, as I am one myself, you might say that this point is moot because you can and should design your application in a way that generally doesn't require manual subscribes like this. And that is fair enough, but the reality is that most developers just aren't building applications in this way, and learning the concepts required to build this way is not easy. An all-in RxJS approach would make Angular very hostile to beginners, and to be fair, really anybody who isn't very familiar with RxJS. The benefits of signals don't end here though, so let's go a bit further. What if we want to combine multiple reactive values together into a new derived value? Once again, signals are quite straightforward. We just create a computed signal using whatever other signal values we want to use. And whenever any of these signals update, the computed signal will update as well. In this example, derived value will initially be 10, and its next value will be 40 after change values is triggered. This is what most people would likely expect. Two values, first it is 10 and then it is 40. So make a mental note of that. We can still do the same thing with RxJS, of course, but things are starting to get a little more complex now. We have to pull in the combine latest creation operator, which syntactically is a bit more awkward, but also comes with some hidden gotchas. Like the fact that as observables, it's possible for the input streams to not have a value, and combine latest will not emit a value until all of its input streams have had at least one value. So this might lead to unexpected results. Combine latest also suffers from the diamond problem. So every time any of the streams the combine latest depends on updates, it will emit a new value using the new value from the stream that was just updated. But what if multiple streams are updated at once? In this case, combine latest will emit a new value using the new value from one of the streams, but the old value from the other stream that updated. Then immediately after, it will run again using both of the new values. So there is this brief period where the combine latest emits a technically incorrect, or we could say transitory value. So whilst the signals version just had two values as expected, 10, then 40, the RxJS approach will actually have three values, 10, then very briefly 20, then 40. So this isn't that big of a deal, I don't think, but it is something that Signals solve with their concept of glitch-free computation. The last thing we are going to compare is side effects. With Signals, we can create a side effect with the effect method. Once again, with Signals, I think it works the way you would expect. We have an effect that logs a message or whatever other arbitrary code we want to run. It will run once initially, and it will run again every time we change the value of any signals it is using, which in this case is just the one. And it's worth noting here that the value actually has to change. If we try to set the signal to 10 twice, for example, the effect will not be triggered the second time. With RxJS, we can similarly achieve a side effect with the tap operator or by doing a manual subscribe. So this is a reasonably common pattern and one that does not appear dangerous on the surface. But there are actually a couple of traps here. If I try to access the count value multiple times in the template by using the async pipe multiple times, it is going to trigger the side effect every time I try to access the value. So this isn't a problem with Signals. And as well as this, since double count is derived from count, this side effect will also be triggered whenever we try to access double count's value in the template, because a subscription to double count will cause a subscription to count. But this is not immediately obvious from the code. So we've only scratched the surface of the sorts of traps someone might fall into if they don't have a deep understanding of RxJS concepts. But even what we have seen so far, I think, is a lot to ask of someone for their beginning experience with Angular, or just of someone who isn't all that interested in using RxJS. Signals are just easier. They cover a significant chunk of the use cases that RxJS covers, and they still provide interoperability with RxJS where required. I say this as a strong advocate of RxJS. For a basic reactive building block in Angular, I think it is just an easy win for Signals. Alright, that's it for this one. If you're an RxJS fan, let's still be friends. I have no desire or reason to stop using RxJS, and there will be plenty more RxJS content coming in the future. And if you found this video useful at all, please consider a like and subscribe before you go about the rest of your day. Thanks for watching, and I hope to see you around for the next one.